Have you ever stopped and wondered what's really going on inside an AI when you give it a complex task? I mean, it's not just spitting out a pre-canned answer. It's thinking. Today, we're going to pull back that curtain, peek inside the machine's mind, and see exactly how these advanced AI agents reason their way to a solution. So let's crack open that black box and see what we can find.
So let's start with a really basic question. Why do the simple AIs, the ones that just give a single, super fast answer, so often fall flat on their face when you give them a genuinely tough problem? What's the missing ingredient?
The answer, it turns out, is a process. I mean, think about it. When we have to solve a tough problem, we don't just magically pull the solution out of thin air, right? No, we break it down, we think through the steps, we build our way toward a conclusion. Well, advanced AI agents have to do the exact same thing. They need a structured way of reasoning to turn a huge challenge into a series of smaller, more manageable steps.
And that brings us to the absolute core technique that gives an AI this power: thinking step by step. Honestly, this is the foundation for everything else we're going to talk about today.
It's a method called chain of thought, or COT for short. And the best way to imagine it is as the AI's own internal monologue. So instead of just jumping straight to a conclusion, it literally talks itself through the problem, laying out this sequence of logical steps that, eventually, lead to the final answer.
So instead of trying to tackle some huge, complex question all in one go, chain of thought creates this nice, linear sequence of smaller, bite-sized thoughts. First A, then B, then C. By solving each little piece in order, it can then synthesize them into the final correct answer. It's simple, but it's incredibly powerful.
And we can actually see this process broken down into really clear steps. First, the agent has to analyze the request, to really understand the core question. Then it formulates a plan, like figuring out the right search queries to use. It even simulates what the likely results will be before it synthesizes all that information. And finally, it reviews its own work for accuracy. This whole structured approach is what makes that final answer so solid and coherent.
But look, a simple straight line isn't always going to cut it. Real-world problems are messy, right? So the next big step for AI is learning how to explore a bunch of different ideas and, just as important, how to correct its own mistakes along the way.
And this brings up a really critical question. A straight line is awesome if you know the exact path from the get-go. But what happens if you take a wrong turn? What if that first approach you try just isn't the best one?
And this is where we see the evolution from a simple chain to what's called a tree of thought. So instead of just one linear path, the agent now explores multiple lines of reasoning at the exact same time, kind of like branches on a tree. It can evaluate all these different approaches, see which ones look the most promising, and even backtrack if a path leads to a dead end.
Now, to make all that exploration really mean something, the agent needs another crucial skill: self-correction. You can think of this as an internal quality control loop. The agent drafts a response or a plan, and then it becomes its own harshest critic, reviewing its work, looking for flaws, looking for gaps, or just ways to make it better, all before it ever shows the final answer to you.
Let's take an example. Say an agent is asked to write a social media post. Its first draft might be something like this. Just bland, unengaging, pretty generic. We have new products. Buy now. Yeah, not exactly going to get you excited, is it?
But then, after a cycle of self-correction, where the agent critiques its own work for being not very engaging and having a weak call to action, it comes up with this. It's dynamic, it's got an emoji, it highlights key benefits like innovation and sustainability. I mean, the difference is just night and day, and it's all thanks to that internal review process.
Okay, so up until now, we've only been talking about what's happening inside the AI's mind. But the real game changer, the thing that changes everything, is when that thinking connects to the real world. This is the leap into action.
And this leap is powered by a framework called REACT. That's short for reasoning and acting. Just think of it as the bridge that connects the agent's internal thoughts to its ability to actually do things in the world, like run a web search or execute a piece of code.
This creates this really powerful dynamic loop. The agent gets a prompt, it thinks about what to do, and then it takes an action, like querying a knowledge base. After that, it observes the result of its action. And that observation feeds right back into its next thought. It's this continuous, powerful cycle of learning and doing.
We can break this whole agentic loop down into 3 pretty simple steps. First, thought. The agent comes up with a plan. Second, action. It executes a tool based on that plan. And third, observation. It analyzes the result,
which then informs the next thought. This cycle, thought, action, observation, is the engine that makes an autonomous agent run.
Okay, I know we've covered a lot of concepts here. So now let's put it all together and see how these different techniques combine to create a really powerful real-world tool.
So if you've ever used an AI tool for something like deep research, you've probably seen an interface that looks a lot like this. You give it a topic, and it just presents this neat, orderly plan, telling you it'll be ready in a few minutes. It looks pretty simple from our side of the screen, right? But this is what's actually happening under the hood. It's that exact same agentic loop we just talked about. The agent generates queries, it does a web search, and then it enters this reflection phase. If the information isn't good enough, it loops right back around to do more research. Only when it decides the context is sufficient does it generate the final answer. It's this whole iterative dance of searching, thinking, and refining.
And all of this leads to a really fascinating idea called the scaling inference law. Basically, it says that an AI's performance isn't just about how big its model is. It's also about the thinking budget. That's the amount of computer time and resources it's allowed to use to actually chew on a problem.
So here's the trade-off. You could use a massive, giant model and just ask for a quick one-shot answer. Or you could use a smaller, more efficient model, but give it a much larger thinking budget to let it run through multiple cycles of reasoning and self-correction. And what's amazing is that very often that smaller, more thoughtful model will give you a much better result.
And the future here is even more exciting. We're already moving from these solitary agents thinking all on their own to collaborative systems. I mean, just imagine an AI council meeting where you have multiple agents debating different approaches, critiquing each other's logic, and working together to find the absolute best solution. It's wild stuff.
And so here it is, the complete pattern. A user gives a prompt to an agent. The agent then engages in this thinking loop, which we now know involves all these cool techniques like chain of thought and ReACT before it produces an output, and, if it needs to, interacts with the user again. This is the blueprint for a truly autonomous AI. So we've seen that these AI agents can do way more than just answer questions. They can make plans, use tools, fix their own mistakes, and actually work towards complex goals. It's a fundamental shift, really, from AI as a simple tool to AI as a collaborator, which leaves us with one last pretty big thought. Now that they can truly think and act for us, what are the really big, complex problems we should be asking them to solve next?